Okay, Namdi. So basically, this video is very important for you. So basically, why are you looking at this flame? Namdi, this is what your flame is. So basically, you see the red tips of this flame? This is the most burn. This is a Bunsen burner. You don't understand the thing. This is, I'm sure more than this is a Bunsen burner. This is from your your Mugu OS security model. Because I don't really like all the systems model. But you know, I have to give a brief. I got the paper there. So I got the paper here. And I got to say, so basically, this is a fire. This fire is burning. This is basically the fire. You can't touch the fire. I can put my hand over the red flame, but science. But you know, the blue flame. I can put my hand, but this is blue flame. So you know, the more I put my hand here, you see this flame is moving. It's dynamic. So by putting your hand on the blue flame, red flame, you are being drawn to the blue flame. So you're gonna lose because you're losing your hand. So you can put over here, but you know there's danger. But this is the danger here. Here, you really know when you hold still, it's hot. But this is just a static system. This is from a static system because you know it's because it's static. Basically, it's static. Why is it static? It's usually the flies, you know, it gives some gas, but the gas is just in the air, so it's releasing gas into the atmosphere. But you know, this is how the structure is. It's static. You know, basically the combustion already happened, and the thing basically because the combustion is stable, the isotope, basically the plasmoid is healing. So basically, if you remember, it's a plasmoid video. So the plasmoid is the thing like the lightning bolt, but the lightning bolt is like the fire can start a fire. So a light can start fire. You know. So basically, a light can start fire. So basically, this is a fire, but it's a type of lightning because you know it's a stable lightning effect. So because it's actually stable, it's stable plasmoid. So the plasma is stabilized. No matter the gas fuel or kerosene, you should charge something. So as I'm doing this, you may not understand this. Basically, you got the model of what do you call it, alkaline and acid. This is the same thing, but build dimension game to it, dimension model. Because now, dimension here is the environment. Now the environment, Namdi, remember as a scientist, is not the actual stuff. It's not actual isotope. What's an isotope? Okay, definition. Now remember, your isotope is like literally what you're doing. So isotope is like say like a nuclear has an isotope. But you know, the nuclear acid you have like chlorine, which is hydrochloric acid. Basically, those are isotopes. You can distill, you can make chlorine less toxic, less. If you go hydrochloric acid and stuff, less toxic. You can have the chlorine in our stomach to break down food. You can have less of it in our stomach and distill it with more water. Because you know, and then the chlorine has to stabilize itself. Basically, it reorganizes itself. Its entropy. So you can break down more food, no matter how much water you drink. So this is this plasmoid here is you. You're not a plasmoid because you're full form. You can talk. You're conscious. You're aware. But this is you know, this is more of the stillness. So the essence of this is when you have a sharp stick and you have without a match, shoot two sticks. You know, you can plug them together in some kind of configuration to start fire. So basically, fire is combustion. You can combust something because you have some kind of way. You do it. So you can have two sticks or branches. You can strike them. Just strike them, and this is why it matters because you know the striking is like the effect. You even need light or some kind of rubber, because light and some kind of wood, flint wood, things are more flammable, wood dense wood, you know, something that's organized in way to ignite. It doesn't matter how much it burns because you can even in the rain. Hence we get forest fires. You know, that's the same. The plasma light bulb plasma is the same thing, but from the sky. So it's basically atmospheric pressure. Basically, the one remember the lightning bolt effect is remember the video on lightning bolt you made on plasma. You know, basically it stabilizes because I'm talking here. The isotopic layer is reorganized and schedule. You get something that's stable. So you can mimic that in your experiment here. Basically, the thing doesn't need to. The variety have its own environment because the environment is there. The thing doesn't need to create a new environment. You know, for example, you get this thing. See the gas? So at this stage, the gas is like burning, but it's not fire. So it's kind of like dangerous, you know, because you know the gas is on. Oh, see, you got off. See, you got off. That's kind of interesting. You got off. You know, I didn't expect it to go off. Sorry. I didn't expect it to go off, but then saying if it did go off, it's not that. So see this gas, you know, it just stopped up. That's kind of thing you need, you know, because gas. I'm not smelling gas. This is what's this? This is not kerosene. What kind of this is? This is fluorine, I think. Maybe it's fluorine. Maybe it's the crazy things for airplanes, for